For millennia, humans have gazed at the stars and wondered, are we alone? The search for extraterrestrial life, once relegated to the realms of science fiction, is now a thrilling frontier in scientific exploration. But we're not looking for little green men anymore. Instead of spaceships and antennas, scientists are searching for subtle but telltale chemical signatures, molecular clues that could betray the existence of alien life, even light years away. Could distant planets harbor life? How do we detect it from such incredible distances? Let's embark on a cosmic quest to explore the molecular clues hidden in the vast expanse of space. So, what are these chemical whispers we're trying to hear across the cosmos? They're called biosignatures, and they're like cosmic fingerprints left behind by living organisms. Think of it like this. Imagine you walk into a bakery. You don't see any bakers, but the aroma of freshly baked bread tells you someone's been there, whipping up delicious treats. Biosignatures are similar. They're the telltale signs of life, even if we can't see the life itself. Some of the most promising biosignatures are gases that here on Earth are strongly linked to life. Take oxygen, for example. We breathe it, plants produce it, and it's a key ingredient in the chemistry of life as we know it. Finding significant amounts of oxygen in an exoplanet's atmosphere could be a strong hint that something's alive down there. But it's not just about oxygen. Methane is another gas that gets us excited. On Earth, it's often produced by living things, like the bacteria in the guts of cows. Finding these gases together in specific ratios could be a smoking gun for life. And of course, we can't forget about the most essential ingredient of all, water. We can't just hop in a spaceship to check distant exoplanets. Some are thousands of light years away. So we use light and technology. Spectroscopy is our main tool. Light reveals a spectrum of colors. Gases absorb specific colors, creating fingerprints. Scientists analyze these to find biosignatures. Telescopes like James Webb help us collect light. We look for patterns indicating life. Let's talk about a particularly intriguing biosignature duo, methane and oxygen. Now, finding either of these gases on its own isn't necessarily a slam dunk for alien life. Oxygen can be produced by non-biological processes, like the breakdown of water molecules by ultraviolet radiation from a star, and methane? Volcanoes can spew out plenty of methane without any help from living organisms. But here's the thing, methane and oxygen don't usually coexist peacefully. They react with each other, meaning that if there's a lot of one, there shouldn't be much of the other. So if we find an exoplanet with significant amounts of both methane and oxygen in its atmosphere, it really makes us sit up and take notice. Why? Because on Earth, the persistence of both gases in our atmosphere is a direct result of life. Plants and algae pump out oxygen through photosynthesis, while various microorganisms release methane as a byproduct of their metabolism. It's this constant biological activity that maintains the delicate balance of these reactive gases in our atmosphere. So, finding a similar methane-oxygen imbalance on an exoplanet would be a pretty strong hint that something is actively replenishing those gases. Now here's where things get even more mind-boggling. We've been talking about biosignatures based on life as we know it here on Earth. Life that relies on water as a solvent and carbon as its fundamental building block. But what if life elsewhere has taken a completely different evolutionary path? What if alien life forms have found ways to thrive in environments that would be utterly hostile to life as we know it? Imagine, for instance, a planet where silicon, not carbon, forms the backbone of life's molecules. Silicon-based life might sound like something straight out of science fiction, but it's a possibility that some scientists take quite seriously, or consider the icy moons of our solar system, like Europa and Enceladus. These moons harbor vast subsurface oceans of liquid water, but instead of being warmed by sunlight, they're heated by tidal forces from their giant host planets. The hunt for alien life isn't just about peering at distant exoplanets. It also takes us on a journey back in time to the very origins of life itself. By studying complex organic molecules, we can understand how life might have arisen on Earth and elsewhere. These molecules are found in the interstellar medium and stellar nurseries. Radio telescopes reveal clouds teeming with organic molecules. Molecules like sugars, alcohols, and amino acids, the ingredients for life. Finding these molecules in space suggests life's building blocks are common in the universe. As we develop even more powerful telescopes, refine our spectroscopic techniques and launch ambitious space missions, the search for extraterrestrial life is poised to make incredible leaps forward in the coming decades. The clues are out there, hidden in the light from distant stars, in the atmospheres of alien planets, and even within our own solar system. Whether we find microbes beneath the surface of Mars, discover evidence of alien ecosystems on a distant exoplanet, or stumble upon life as we've never imagined it, one thing is certain: the quest to solve the mystery of our place in the cosmos will continue to inspire and challenge us for generations to come. So what do you think? Are we alone in this vast and awe-inspiring universe, or will we soon find the telltale chemical signatures that reveal the presence of our cosmic neighbors?